partnership agreement. We are joining forces to educate and build capacity when it comes to quantum computing and cybersecurity for manufacturing sectors. We'd be happy to welcome her on the stage. And the stage is yours, and thank you so much. Whenever things has happened, but she made it today. We need this week. Please help us out with this.
For having us, Derma Group. Thank you, Max Live. Thank you, Yasmin, for all what you are doing. And as Yasmin highlighted, actually it will not be possible to do what we are doing without partnerships. Partnerships are the backbone of advanced technologies, are the backbone of development, and whether it's expertise or solutions or investments or whatever you can say it, without partnerships we cannot move forward. When we talk about partnership, we talk about joint go-to-market. We talk about adoption of the technology itself. We talk about how solutions can bring value to the common good of the nation. First of all, that's the highest aim that we target. And the other aim also, of course, is commercialization when we are working on for profits. So the road cannot be gone on a lonely basis. It needs to have others. It needs to have partnerships. Partnerships need to be sustainable in order to move forward. Without sustainability in partnership, thereby each party will think that can do something alone, and ego comes in the picture, it will not move at all. There's a friend of mine, and he is one of the first movers in the quantum commercialization in the world, and he is the head of Quantum Basel, Damir Bodran. What he says we need to move from egocentric to ecocentric, so ecosystems. Economy needs to have ecosystem, needs to have partnerships. So by saying that, it's important to introduce first of all myself, and the other point is the technology itself and why quantum. Actually, I need to move to get rid of this one. And then the slides on the side. Can someone help me, because it's set up to be this way? So I would like to have just one. Can you help us? So if I want to have a presenter, we need to does and that's all. So I don't have this. So it's probably like the second. So first of all, I will try to the time that this is done is try to introduce Bernwell, and it's been since some time that Bernwell, the first company, it was Space and Tech. It was funded in 2020, and the foundation of the Bernwell Space and Tech at that time came that the next movement of the technology, and remember very well, it was 2020. In 2020, who heard about quantum technologies? Who heard about quantum computing optimization for manufacturing, for example, in 2020? 2021?
Yes.
Okay, of course.
Because I start to know you.
Exactly. Okay. So we started in 2020, and the start came from a background, and it's probably for so many in manufacturing, it's a weird background. My background is law and economics, and I work on space technology, space law, international business law, specific into space, and technology that has implication on national security. And when we talk about space technology, AI and others, more and more you will see the friction between the commercialization and the way how worldwide the technology is fine and smoothly adopted, but you will see always export control come into the picture when we are talking about hardware and when we are talking about also software, because that technology can have dual use. And that's what got me into the quantum and AI and all these kind of disruptive technologies and cybersecurity, of course. And we are a partner of a proud partner of the Cybersecurity Council in so many activities that we are doing, which is the government entity, in the federal government entity that overview the cybersecurity, and they are the regulator of cybersecurity in the country. And probably to say also that the UAE in the index of cybersecurity is, I'm not sure about the name exactly, but in the index is #1 nation in the world. So that to say that we are not only adopting new technology, but we are moving ahead in the UAE with how technology is used and how technology is channeled while the cybersecurity and all kind of security under national security is upheld, and it's moving one of the full-fledged #1 nation in the world. So at that time, I started really studying about quantum and implication of national security. It was in 2016, and you can Google it now if you want. The first satellite sent to space, it was in 2016 by China, and that satellite was supposed to be quantum-based communication satellite. So for me, coming from the space industry, for me, quantum satellite, how this is possible, quantum communication, I never heard about it. It was in 2016. China started beaming quantum communication in 2017, and today they have the largest communication network in the world, China, and they have thousands of kilometers of underground cables that it is based on quantum physics. And why that it was important for me and triggered me, because I say this is new technology and it's already touching space. It means like what is the application on space technology and on national security, and also how the future of communication will be happening. So that opened something in my mind, and I started, of course my background is not a technological background, it's not engineering or anything, so I started even going to physicists and trying to have continuous learning. That's why training, whatever is your background, your PhD and whatever, if you do not understand something while it touches your everyday life happening, or your work, or even curiosity, it's important to understand and to take some trainings and to assist into these kind of open source gatherings that you can learn something from. Of course, probably you know quantum better than I, maybe. I'm sure you do. So yeah, my colleague will be presenting later on the software, how it works. So in a nutshell, the first company was a touch base on how bringing different kind of disruptive technology in the region while I was working in the space industry for so long. So it was to my really surprise, the first technology that we moved forward to be here today with various partnerships and talking about the adoption. We're working on a strategy for different countries countries and different entities, and we are talking about partnerships with government. And that one, it was a lonely road from 2020, but after 2024, we created the first Quantum Innovation Summit that puts the UAE in the map of the first nation that is convening various leading quantum entities, governments, others from United Nations and so forth, to speak about quantum. And now, today, we are leading the quantum revolution in the region. Of course, I'm not going to say Bernal is doing it. We are, as a community, doing that. And the top of the community is the Technology Innovation Institute, which is the research arm of the ARTCA, which is the Advanced Research Council, headed by His Excellency Faisal Al-Banai, and Technology Innovation Institute is headed by Dr. Najwa Arash, who's doing a great job. So they have the best of researchers in the world, and then we are hosted in the UAE in Abu Dhabi, the first quantum computing that is done and it's made with a researcher in Abu Dhabi in the UAE. And what is very important, why I bring all this background, is important to know what's happening. First of all, business intelligence is number one thing. If you are in an industry which you have competition, you have other players, and how you improve your operation, how you improve yourself in order to move forward to the next step. So when we talk about quantum technology, I stop here. I will not go through. You can go to vermalgroup.com. You will see what are the different companies that we are having, because at that point in 2020, the first big bottleneck for me was capacity in terms of who will be working with me to work on this strategy and on the company to provide knowledge to do this, because at the end of the day, we need scientists. And at that point, I hit with the first truth. It wasn't possible, because most of the scientists who are in there in this field, they were from outside of the country. So it was difficult. We could hire, train, and after some time they are good, they leave, and all these kind of things, because you put money and time and energy in order to create a know-how for someone, then after that he goes away. Alhamdulillah, today is not the case. We have, mashallah, so many new graduates from different universities that are in computer science, they are in AI. Thanks to the partnership that we have with different universities, we started with Abu Dhabi University, we created the first quantum computing lab. We provided for them the NMR quantum portable computing coming from a company called SpinQ. It's a Chinese company, it's the first to provide these kind of computers, which you have it on your desktop. It comes with curriculum, and actually you can even work you drag and drop your qubit. You will show that later on, but that was for education, and it was limited. So fast forward, today we partner with one of the best companies, have end-to-end quantum computing software that the most advanced company in manufacturing or in any other industry, they can use this platform to optimize, to work on AI, and to do the other job that my colleague Musi will present. So many people, if you are not familiar with quantum computing or quantum technologies, we see so much sci-fi before, and in the sci-fi, beam me up, Scotty, and you see this is quantum teleportation, this is this and that. So many people, they think that quantum is still science fiction. But actually is quantum technology science fiction? No, we remove the fiction out of it. It's been science more than 100 years. Are you familiar that this year it's the 100th year of quantum technology and science? It was proclaimed by UNESCO and under United Nations Assembly. This year, 2025, worldwide, we celebrate the 100 years of quantum science and technology. So are you familiar with that? Did you see anything happening related to this? We've done a lot of conferences in the UAE, activities around the world, so it was a big deal for everyone. and actually the first Nobel Prize in Physics 1980, it was this gentleman, Max Carl Ernst Ludwig Planck. So Max Planck, you heard about Max Planck. He was the first one who is the Nobel Prize in Physics 1918 was awarded to him in recognition of the services he rendered to the advancement of physics by his discovery of energy quanta. And actually, he's one of the pillars of the quantum science. So quantum science exists since 100 years. So what is the difference then between the quantum 1.0 and the quantum 2.0? So the quantum tech 1.0, it has fundamental. And today the quantum technology 2.0, these fundamentals, they were harnessed much more to manipulate it in order to do different work. So the quantum tech 1.0, among the fundamental, and this is a comparison, so it focuses on the initial practical application of quantum mechanics. Actually, it utilizes quantum mechanics principle in limited capacity, very limited, mainly focused on enhancing existing technologies rather than creating a new subsets of technology, new mode of computation and communications. So you are familiar with, I'm sure, I hope not, but I'm sure most of you, they know when we go to do the MRI, the MRI is based on quantum physics. It's quantum technology 1.0. LED light also, it is. So when we talk about quantum tech 2.0, it's much more advanced. So it embraces full quantum mechanical systems, and it unlocks new capabilities and mainly focuses on the manipulation of quantum states, leading to groundbreaking applications. I'm not going to go through the scientific thing that I learned, and the non-locality, for example, if something happened here and you are on quantum state, for example, the communication is immediately without any latency or whatever, it's propagated to the other side. You can do it. You can trace it. And I'm not going to go through the science. Probably, yes, Tamusi will say some of those characteristics. It's when I say I'm on quantum state, I'm here and there and everywhere. This is quantum, Entanglement is one of the words you hear. I'm entangled. Is quantum entanglement is one of the other principles that it is based on science. So the characteristic of quantum tech 2.0. It's first of all the development of technologies that are inherently quantum. So it's the manipulation of to the atomic level of these characteristics, such as quantum computing. These technology, quantum computing, quantum communication, and quantum sensing. Are you familiar about quantum sensing in a way or another? Okay, you're. Of course. Can you tell me in a nutshell if you can tell us?
No, I wanted to tell, because I am familiar because I'm the person who invested in education.
Exactly. So actually, but sensing in general, sensors. The sensors that we have.
Your cars and your factories, they're from the
Robotics, exactly. Robotics, it has a lot of sensors, and those sensors are the normal sensors. But actually, when we are talking about quantum sensors, and this is a call for you, please, to read about it. A lot of people, they know quantum technology based on quantum computing, but I would say, no, quantum computing is one of the technology. There are some other subsets. They fall under the scope of quantum technology. So quantum sensors are the sensors that are very, 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 very sensitive to the magnetic field, and please let me know if I forget something that you can explain later to clarify. And actually, you can detect the fluctuation of energy into the smallest, it couldn't be detectable by normal sensors. I'll give you the example, for example. China recently, they announced that they have a new quantum sensing able to discover stealth technology. We know very well stealth technology is very important for defense and security, and submarines, for example, for like Navy, military submarines in the water, most of the time they are stealth, and they function stealth-wise. And we have some airplanes that are very well known. They are stealth airplanes. They're not detectable to the radars, to the normal radars. Well, China, what they said they come up with the quantum sensors that they are able to detect that. So this is how highly sensitive the technology is. And if you do that into robotics, I mean, you are unlocking another way of functioning. Of course, some of the bottlenecks there are the miniaturization of the technology itself to embed it in small gadgets like robotics and whatever. But it's something that we work on. For example, quantum sensing. We presented during the Quantum Maritime and conference in partnership with Abu Dhabi Maritime Academy, and it's sponsored, supported, and in partnership with 80 Ports Group. And one of the activities that are involved and were presented is how quantum sensors can save the ships from the GPS denial, which is something that is happening a lot, whether it's like related to boats, ships, or related to airplanes, because it happens. And this happens always when there is some warfare, for example, recent wars, like in Ukraine and Russia and so forth. They do kinetic weapons or whatever. So the GPS will be, and they make some different capabilities in order to cause the denial of GPS. And actually, can you imagine airplanes and with the navigation systems and everything, they lose their tracks and they don't know where they are, or ships are also the same. It's a big deal. Then communication. And here I invite you to read about what TII has done in partnership with the UAE Space Agency. They have the first ground station, which is based in Abu Dhabi. So you read about it. It's quite impressive, and this is one of the activities that Technology Innovation Institute is moving forward in order to create secure communication based on QKD and other, which is quantum key distribution and secure communication based on quantum technologies. So the harnessing of core quantum principles like superposition, as I said, entanglement and tunneling, they are they are now in action, and they are the basis of quantum technologies. Please watch out, because some people they would say quantum computing, or what they would say is quantum inspired. Both of them are not the same, and also quantum simulation. And you need to know the difference, and probably you can ask them later on to tell you the difference exactly. There are methods in between. So it's a little bit tricky, because you will see a lot of hype around it, and some company use this misunderstanding of the details in order to move it forward towards some kind of publicity advertisement, which can mislead the others. So the potential to revolutionize a field like cryptography. Have you heard about post-quantum cryptography? Okay, what are the basis of the cryptographic systems that we are working on today? So, like for example, if you are on the internet, there's exchange of there's cryptography basis on it. So actually, this cryptography, it's threatened to be broken by what we call it a very I would say it in the right term, not very powerful quantum computing, because it doesn't mean anything. But I would say based on cryptographically relevant quantum computing, and this quantum computing is the characterization is there based on the various scientific papers, is how many qubits in the quantum computing with the different other characteristics that will be able to break the current, for example, RSAs. And this is based on two algorithms, short algorithms, so another word that you can read about it, and grow up algorithm. So these are the two, which are the potential basis of this threat that quantum computing is able to bring. So actually, so many companies, entities, governments, and international institutions that are working now on the transitions from the cryptography that we have today into the quantum safe cryptography, or with quantum safe solutions. And that is very, very important because the Cybersecurity Council also is working on a new regulation related to that. And important to watch out this space, because if you are in manufacturing, if you are transitioning data, critical infrastructure, and all this is very important to look at into the threats of quantum computing on the cyber security that we have today and what needs to be done. So when we talk about unleashing the power of quantum technologies, the quantum computing, it utilizes qubits. It leverages, like I said, superposition and entanglement. It has the potential to solve certain classes of problems faster than any classical computers, or faster of any combined classical computer in the world. And here you can see and read what are the state of quantum computing, because today we are still, as companies, from the hardware side, they are still working on some bottlenecks, which are the error corrections and the number of qubits. When we increase the numbers, how it can be stable in order to do the computational that we are aiming to have, and how we scale up with the hardware. So if you read IBM, what they are doing, I will explain to you in a minute the state of different hardwares and what are the possibilities of quantum computing in the near future when we achieve advantage. So do you understand exactly what quantum computing can do for and what it is for? Did you get the picture of once we are speaking about quantum computing? So quantum computing, it will not be like our, for any time soon. It will not be something that we're going to use every day like this. It will be basically the hardware. It will be put in different data center, for example, and depends of the technology itself, because if we are talking about superconducting, it's quite expensive and it needs a huge infrastructure. And if we are talking about photonics, there's a problem today with the companies. The photonic quantum computing are not scaling that much because there are some bottlenecks with the technologies, of course. And if we are talking about some others, annealing like D-Wave, they are doing some of the job, but it's really expensive. So that's why Venmo Group, we got, after years, after 4 years of doing the market, dealing with these companies, working on some use cases, working on the initiative on the scale of the national scale and international scale in order to adopt the technology. We found a partner who we know since the beginning that the partner is called Classic, and they have one of the platforms which is a very advanced platform with a fraction of the amount that you could use for the access to the hardware directly, because it's really, really expensive right now. So to work on the algorithms in order to optimize, for example, problems that you have in manufacturing, it will be very difficult to pay much, especially if you don't have quantum computing scientists in your premises in prem to do the work that you are trying to do with the results that you want to achieve, which to show your investors or your clients or whoever that the investments it's worth the ROI. I mean, the ROI is worth the investment that you've done. So that's why my colleague will present the platform, which is going to facilitate different bottlenecks. First of all, the direct access to the quantum computing is really expensive in order to do all the work. Different quantum computing, they have different languages, and in order to do that, you need to have a background of the language. The other problem also is price point and the deliverable that you need to be making. And one of the most important part of the platform that we will be presenting today is the fact that one of its worth is the compiler, which is connects the different quantum computing hardware that transform or translate from Python or other coded language into the language of the hardware. Am I having a good presentation so far? So
Yeah.
because he's this
I will
expert.
explain.
Okay, fine. So he will explain later. So when we are talking about quantum computing, we do different activities on quantum computing. Optimization, like for example, logistics, finance, quantum chemistry and material, okay, simulation, and cryptanalysis, which is very, very important. So the quantum sensing, like I explained earlier, it explores superposition, coherence, entanglement, and ultra-sensitive measurement in order to be used in navigation without GPA. So this one, it's called quantum gyroscopes. Also, it's used in medical images, quantum MRI. We have the MRI, it can be quantum MRI. Geoscience and defense, like gravimeters and underground submarine detection. So can you imagine this technology we can do? And this is just the tip of the points that we are unveiling, not us, but the biggest researchers who are in the defense industry. So the quantum communication, it transmits information via quantum states of photons, core principles, quantum key distribution, QKD. It is against, if you have, if you are using these keys, and we are always with our partners from different entities, like for example, ID Quantique, they are one of the most famous companies who started before everyone else, who they started I think 2001 or something like that, if I'm not mistaken. I met them first time not long ago, it was 2019, I believe, and since then we are always going to conferences and others, and we invite them to create a kind of awareness about what they are doing. So actually, you are familiar with cybersecurity eavesdropping, and when you are having a channel of communication between Alice and Rob, and if someone wants to intercept in the middle, if it's QKD, if it's quantum-based communication, as soon as you have someone intercept, it will be, you will know that someone did try to what they call it, the same word, is to manipulate the system, and they cannot get access to the data. And so it enables quantum safe networks and quantum internet. So the next step is the quantum internet. So this is having networks quantum-based and formed in quantum. So after 45 years of research on quantum computing is nearing an inflection point, and now we are in this inflection point. So here, if we are going to see the way how it's happening, from 2016 to 2023, we have from 5 qubit to 1,000 noisy qubits. And the qubits are the quantum bits that make the calculation or process the information. Here, with a normal computer, we are working on bits. So this is the difference. This is qubits and this is bits, and that's the main major like idea about it in order to understand. So the way how IBM, for example, it worked from the start as a research, and I talked about Shor algorithm. So we have in 1995, you can see the problems that came to the surface, which was a publication by Peter Shor, who said that when we achieve this much of qubits of quantum computing, actually you will be able to break the RSAs. Okay, so it will be making the calculation to do that. Here also it's like if you want to go and check, you will see what the gentleman, of course, everyone knows, the CEO of Alphabet of Google, the CEO and chairman of Microsoft at that time, what was said. So from 2023 to 2025, error correction leads to logical qubits, which is an advancement compared to the noisy qubits, because when we say noisy qubits are very low quality qubits able to process the information. Then we expect 2026 to 2027 the quantum advantage. That's the inflection point whereby the quantum computing will be able to supersede the results that we are achieving today through our existing calculation, whether through the supercomputer or others. Is at that point, it's the companies like IBM, IonQ, the main companies, IBM, IonQ, Quantinuum, and others, they are working toward achieving that advantage point. And that advantage point is having a quantum computing useful for the calculation that we are aiming to be having. So 2028 to 2029, if we see that IBM, in its strategy, they said first error correction quantum computing will be in 2028. And actually, this slide is done a little bit before the latest strategy shared by IBM. So if you go and track it, more and more we advance, the time of to achieve the whatever we need to achieve in order to move away from this bottleneck toward having a very powerful quantum computing to achieve advantage and others, the time is shrinking. And this can inform us one thing: the time to transit to the quantum safe cryptography is also getting smaller, it's shrinking, and we need to move forward today and not tomorrow. Can you imagine that now entities are going through their libraries of cryptographic libraries to make inventories, and we talk about tens of thousands of cryptographic algorithms and others which are in one entity in order to see if these could be quantum safe or not, and actually based on the inventory that is done, what is the next step to implement and so forth. And this one, you can watch the work of Quantum Gate, which is a sovereign entity in UAE, in Abu Dhabi. It's a spin-off of TII, Technology Innovation Institute, and their work is tremendously amazing because they are working with most of the entities, federal and other entities, in order to transit into the post-quantum cryptography. So I move to the next slide. So the motivation to unlock $2 trillion in value across industries. So this one is McKinsey company, and actually I think they have another one which is 2025, it's out. This one is the earlier one, I believe. So probably it's the same, there's not a lot of changes is done. I need to make sure it's the case or not. So here you can find out which industry will be moving forward before the other in order to adopt, and what is the outcome of each when it comes to the economic value. And actually it's done based on the different they created a different timeline in order to move forward. So if you see, for example, chemical industry, okay? So the chemical industry, it will be between 2025 and 2030 that will be having a greater value. And that shows when we talk about the chemical industry, most of the manufacturing, actually it's most of the manufacturing industry is relying upon chemicals. So this is important. Also, we see here, we talk about logistics, and my thing here, they put travel, transport, and logistics all together. And my intake in this, they should have done the logistics separate, because logistics are the most industry, is the industry that it is using mostly optimization of quantum computing and quantum inspired. So they should have done separate, because today we work on logistics already. And